Some more problems from section 10.2, not 7.2, 10.2. And again, we're trying to find the magnitude and the direction angle. Well, again, this is is in the form of, it's in the standard, or component form, I should say. So AB, so again, we know the magnitude of the vector, right up over here, the magnitude, just equals the square root of the components, horizontal component and vertical component squared. Square root of 3 squared plus 1 squared. That's just going to be equal to the square root. The square root of 3 squared is 3 plus 1, which is the square root of 4, which is just 2. So that's pretty straightforward. And then we want to find the angle, so we'll draw a sketch. Remember, it's in its component form, so my horizontal, this is 1 and this is 2. We know that the square root of 3 is about 1.7, so horizontal position would be 1 and 0.7 about, and something like this, and up 1. So we could also write these as the coordinates, square root of 3, 1. We want to find this angle. So the vertical position will be 1, and the horizontal will be the square root of 3. So again, the tangent, we've got the opposite and the adjacent. We could also get this because it's 2, so we know that that's 2. But even just using these, we know that the tangent of theta equals the opposite over the adjacent over the square root of 3. And what angle has a tangent of 1 over the square root of 3? That's pi over 6, or 30 degrees. So there's your angle. Oops, pi over 6 stars. Excuse me. This implies, I should say that, this implies that theta equals pi over 6, which is 30 degrees. Okay, so if the tangent of theta is 1 over the square root of 3, then we know that theta equals pi over 6, or 30 degrees. And that's your angle there. Okay, hope that makes sense. And you could have taken the arctangent of both sides to do it more formally, but it's pretty intuitive. Okay, let's take a look at number 9. Same thing, we want to find the magnitude. Well, again, this is A and this is B. The B is 0, so the magnitude of the vector, we call the vector V. And that's the notation for the magnitude. That's just going to be the square root of A squared plus B squared, which is just going to be the square root of negative 5 squared plus 0 squared. That's just going to be equal to the square root of 25, which is 5. So my magnitude is just 5. And it's just going to be, in this case, it would just be the horizontal component, the absolute value of that. That's all. Okay, so that's pretty easy. And then we want to sketch it to get an idea about our direction angle. Okay, we know this is kind of in the component form, so this is going to go like this, and it's going to go out here. And let's just say this point's negative 5. So it's going to go out to the point, so the horizontal displacement will be negative 5 or 5 to the left, and there's no vertical displacement. So what's our angle? Our direction angle is the angle that it forms with the positive x-axis, so this is the positive x-axis here. So what's that angle? And this is the component form will be the terminal side of the angle. That's the initial side, so that's the angle, and looks like I'm going 180 degrees. So theta would equal 180 degrees. That's the direction angle. So that's all you have there. Okay. On number 11, Find the component form of the vector with a given magnitude that forms the given direction angle with the positive x-axis. So we have magnitude of this vector, we'll call it v, is equal to 4, and theta equals 180, 180 degrees. Okay. So I'll draw a sketch. And this is what we call the standard representation. So when we have the standard representation, that's what we're looking for. So basically we have our angle, so we could kind of sketch it from our angle and our magnitude. And our angle is going to be 180 degrees, and then our magnitude is going to be a positive 4. Or it's going to be 4 is the magnitude, but the angle is 180 degrees. So again, this would be the initial side. So this is going to be the terminal side. So my ray is going to end up here, and it's going to go out like this. Kind of like the reverse of number 9 here. Except the magnitude is going to be 4 instead of 5. So the magnitude is the absolute value, but since it's 180 degrees, this will actually be negative 4. So you can see the magnitude of this vector is actually 4 units long, so it would just be 4. And the direction angle is 180 degrees, so that's what we've got. So they want the representation for this. So if we look at this end over here, this is going to be at the point negative 4, 0. So then we would write that in vector form. We could say our vector will equal horizontal component negative 4, I'm going 4 to the left, and vertical component 0. So that's what it would be. That's what it would be in the vector form. And when it's in what we call the standard representation, that's when the tail is at the origin, then basically the components will also be the coordinates will also be the same thing as the components because they represent the horizontal displacement and the vertical displacement. Okay? So that's number 11.